Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized conversations. Today we're looking at a paper that sounds like it's straight out of science fiction. It's called Space AI, Leveraging Artificial Intelligence for Space to Improve Life on Earth.
It really does, but what's amazing is that this isn't about the distant future. It's about what's happening right now and in the very near future. The paper argues that we need to start thinking about AI in space not just as a tool, but as a whole new scientific field, space AI.
So what does that actually mean? Is it just, putting ChatGPT on a rocket?
Not quite. The key difference is autonomy. Space missions operate under constraints we just don't have on Earth. Think about the Mars rovers. There's a communication delay of up to 20 minutes each way. You can't control it with a joystick in real time.
Right. If the rover is about to drive off a cliff, you can't hit the brakes in time. It needs to be smart enough to see the cliff and stop itself.
Exactly. So space AI is about creating systems that can perceive, reason, and act on their own, millions of miles away, in harsh environments with limited power. And the paper breaks this down into 4 key areas, starting right here on the ground.
Okay, so the first area is AI on Earth. That seems a bit counterintuitive for a paper about space.
You'd think so, but all space exploration starts here. This is about using AI for everything that happens before launch. Imagine trying to design a new rocket engine. AI can run millions of simulations to find the lightest, strongest, and most efficient design, exploring possibilities a human engineer might never think of.
So it's like a super-powered design assistant. The paper mentions something called digital twins. What's that about?
It's one of the coolest concepts. A digital twin is a perfect virtual replica of a real spacecraft. You can test everything on this digital model, how it handles radiation, extreme temperatures, system failures, before the real billion-dollar satellite is even built. It helps iron out the kinks safely here on Earth.
That makes sense. Get all the mistakes out of the way in the simulation. So once the AI-designed, digitally tested rocket launches, what's next?
That brings us to the second area, AI in orbit. This is all about managing the increasingly crowded space around our planet. Think of it like air traffic control, but for space.
I've heard low Earth orbit is getting pretty busy with all the new satellite constellations.
It's a cosmic traffic jam. There are thousands of active satellites and hundreds of thousands of pieces of space debris, all zipping around at 17,000 miles per hour. A human can't possibly track it all. So AI systems are now in charge of intelligent space traffic management. They predict potential collisions and can automatically tell a satellite to move out of the way.
So it's like Waze for satellites, automatically rerouting them to avoid a crash. That's incredible. Okay, so we've covered Earth and orbit. Let's go deeper.
Let's. The third area is space AI and deep space. This is where true autonomy becomes absolutely essential. This is the world of the Mars rovers, like Perseverance.
This is the 20-minute time lag problem we mentioned. The rover has to be its own geologist.
And it is. The paper gives a great example. The Perseverance rover has an AI system that lets it identify interesting rock formations on its own. After a drive, while it's waiting for instructions from Earth, its AI can spot a promising rock, zap it with a laser to analyze its chemical makeup, and send that data back. It makes discoveries during its downtime.
That's so efficient. It's not just driving and waiting. It's actively doing science the whole time. It's a genuine robotic explorer.
Which leads us to the final, most ambitious stage, AI for multiplanetary life.
This is where we get into building bases on the Moon and Mars, isn't it?
This is it. The paper talks about how AI is the key to making this possible. You can't ship every nail, brick, and bag of food from Earth. It's just too expensive. You have to use what's there. The technical term is in situ resource utilization.
A fancy way of saying living off the land.
Exactly. So this means AI-powered robots that can 3D print habitats using Martian soil. It means automated greenhouses managed by AI that can grow food for astronauts. It's about creating a self-sustaining presence, and that requires an intelligent robotic workforce that can build, repair, and manage things without constant human help.
It all sounds amazing, but the paper's title promises that this will improve life back here on Earth. How does building a base on Mars help us down here?
That's one of the most important points. The technology developed for space has huge benefits for us. The AI that learns to manage a closed-loop life support system on Mars could be used to design ultra-efficient smart buildings on Earth.
And what about all those satellites in orbit?
The AI systems analyzing satellite imagery aren't just looking for space junk. They're monitoring deforestation, tracking the effects of climate change, and providing first responders with real-time data during natural disasters like wildfires or floods.
The challenges of space force us to create smarter, more efficient, and more robust AI, which we can then turn around and use to better manage our own planet.
So, in a way, by aiming for the stars, we end up taking better care of our own world. That's the vision this paper lays out. It's not just about exploration for its own sake. It argues that space AI is a critical field that will push humanity forward, enabling us to become a multiplanetary species while also giving us the tools to be better custodians of Earth.
A powerful idea. From designing rockets on the ground to building cities on Mars, space AI seems to be the quiet force turning science fiction into reality.
Absolutely. It's less about a single aha moment and more about a fundamental shift in how we approach the final frontier, not just as visitors, but with intelligent partners leading the way.